Hello and welcome to our demo presentation of the fairsearch library, the first open source library for fair rankings. We implemented two fair ranking algorithms named fair and delta, as you can see here, and they are available in Python, Java, and as a plugin for Elasticsearch. So you see here, this is the plugin for Elasticsearch for the fair algorithm as a Java library, and as a Python library, and down here are the same three packages for the second algorithm delta. So in this video, I'm going to present to you one of these algorithms. In this case, we're going to present the fair algorithm, explain how it works, and show a short coding example, and afterwards an example application that uses the Elasticsearch plugin. But first, let me tell you why we think that fair rankings are important. Ranking algorithms have proven to be discriminatory against minorities, and this is done by decreasing their visibility and therefore reducing economic, educational, and social opportunity for already disadvantaged groups. And we believe that we need algorithms that do not reproduce these discriminatory patterns which are still present in society. So let me show you this example here. This is an example of a Google image search for a CEO that I performed in 2016. And we see that the images only show pictures of male CEOs. So here you see the first page. And as you can see, there is only, and on page 3, we actually see the first woman to ever appear, and she's up here and it's Barbie. So it's not really a professional photo of a professional female CEO. And then it continues like that, and the first professional, like a real professional photo of a female CEO is on page 5. And this search result does not cover the male-female ratio of CEOs in the real world, and it will reinforce our stereotypes as a CEO to be a male profession. So with fairsearch, we made a programming library available to mitigate such problems. And one of the two implemented methods is called fair, as I said already. It's a post-processing method that reorders an existing ranking to meet certain fairness criteria. Now let me show you the main functionality of this package here. So the algorithm is based on 3 parameters. They are called K, which is the length of the ranking. P is the minimum proportion of protected candidates. So we have 2 groups in this setting. One is protected and the other one is non-protected. And this P reflects how big is the proportion of protected items that I want to see in this K elements. And then we have alpha, which is the significance level, because the fair algorithm is based on a statistical test and it needs a significance level. The first thing we do is we create a fair object with these 3 parameters, and then the algorithm operates in 2 phases. First, it calculates an array called an M table, which is a representation of a fair ranking with the minimum number of protected candidates. So we have this function that is called create adjusted M table, and that's going to create an array that looks like this. And what this tells us is that in the first 8 positions, I need at least 0 protected candidates to meet the fairness criteria with a P of 0.25 and a K of 20. And then in the 9th position, I need at least 1 protected candidate. Then on the 16th position, I need at least 2 protected candidates to meet these fairness criteria up here. Now we create an unfair ranking, and this has 20 documents. And each document has a document ID, that's the first number, and it also has a score, that's the second number, and it has a protection status. And true means down here that the document is protected, false means it's non-protected. And we see if we print that this ranking is not fair to meet these criteria that are reflected by this M table. And if we call a test function that asks if a given ranking is fair, it obviously returns false. The second phase is that we can use the fair object to re-rank our unfair ranking. And if we do that, it's going to reorder the items according to the aim table that we had above. So because we said that at the 9th position we need at least one protected candidate, this is reflected here. So the re-ranking is going to move up the items from the protected group to the positions so that the fairness criteria that are reflected in the aim table would be met. And if we now execute the isFair function again, we're going to see that it returns true and that the ranking that we have here now is a fair ranking according to this K and P. Now let me show you what happens if you set the P a little higher. Okay, so the first thing that's going to happen is we have a different M table here. Now what we require is that there is at least one protected item in the first 5 positions instead of in the first 9, at least 2 protected candidates in the first 8 positions, and so on and so forth. Now again, we have this unfair ranking. It still looks the same. Now again, if we execute that statement, we will still see that it's unfair. And if we re-rank that, it's going to be re-ranked according to the new M table. So what we will see is that there is a more even distribution between the protected and non-protected items. Okay, and voila. So we see that the first protected candidates now appears on position 5, and this was also what the M table was requiring. So to better illustrate the functionality and interplay with the Elasticsearch plugin, we've also built a demo website that retrieves candidates for given job queries. So here you see that we have a search field, and up here you will see the fair algorithm parameters with a few predefined settings here. And we're going to start with an unaware ranking, and I'm going to search for science. And then we get, in this case, 20 candidates. And because this ranking is unaware, that means that all the candidates that are retrieved are solely ordered by some sort of relevance score they have, and the ranker does not consider any sort of protection status. So here the blue lines are the ones that belong to male candidates, and the sort of pinkish lines belong to the female candidates. And in this case, we have females as a protected group because they are the minority in this ranking. So, and now if we switch from unaware to a ranking where the protected proportion is 0.2 and the significance level is 0.5, and we search again, we saw that these 2 items were swapped, right? So this female person has previously been on position 13 and this one has been on position 12. So these 2 guys are now swapped to meet the fairness criteria that are reflected in the M table that is built underneath this whole website. And now if we set the protected proportion even higher to 0.5, we see again that in this case these 2 people are swapped and the female candidate is ranked to a higher position. And then in this website we can also have custom values here and set the protected proportion to, let's say, like we have a ridiculously high value, then we're going to push all the females to more or less the top. This is of course not something that we desperately want, but yeah, we can play around in this custom setting a little bit with the significance level and the protected proportion. So I hope you enjoyed today's tutorial and that you also enjoyed the Fair Search library. I hope you're going to use it in your future projects. And if you have any questions or anything that you'd like to know further, if you want to contribute, contact me, check out the GitHub source codes, check out the other demos that we have there. And yeah, I'm looking forward to present that at the web conference in 2020.